All right, welcome to the last video. And Rick and I are going to take you on the last section of the journey here. Okay, and we are going to get ready to go and current slide. All right, so you've all heard about the James Webb Telescope and how amazing it is. And you're probably most excited about the really super sharp photos, right? But for scientists, the photos are great, but we're both chemistry chemistry nerds. So for us, amateur astrochemists, the fact that the James Webb can do spectroscopy, studies chemistry. So these exoplanets, we can start looking at their atmosphere, not just finding them, but then looking at as much of their chemistry as we can tell from a distance. Because as we discussed, right, it's looking at physics leads to chemistry. Chemistry is what is the emergent environment for biology. So,
and just as soon as it becomes easily available to the James Webb, in other words, far enough away from the sun in the sky as the Earth and the James Webb move on around the sun, sometime late spring, early summer, they're going to focus the telescope on the TRAPPIST solar system.
oh, I didn't know that.
No
Exciting.
fewer than 7 rocky planets have been discovered.
Yeah.
That's one fewer than our own system. And I believe it's 3 of them are in the
They are
in the
surface water zone.
the surface water zone. So the Webb will be used to actually study the atmospheres of these planets. For the first time, we'll get real data on an exterior solar system.
So looking ahead to other resources, right? Look for books by astronomers as a preference to even science writers are secondary sources. Astronomers are primary. Some science writers are just excellent. I'm not maligning science writers, but start with Imagined Worlds by James Trefil, and Exoplanets Netflix has a series called Alien Worlds. The fact that it's Netflix doesn't fill anyone with joy necessarily in terms of good quality, but it's done by the BBC, which we all bow down to. So yeah. There's a class in the Great Courses which you have to pay for called Exoplanets. There's a class in Coursera, 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 which you can take for free. It's a long, complex, professional astronomers, major university, primo option. And did I mention free? I think it's called astrobiology. Okay. You can also look, there's another class on exoplanets, just in general. So just if you're interested in the subject, and for the third time, it's free. Okay. When you get to the payment page, go don't panic. The first 3 options are things that you have to options to pay and get credit and so forth. And down at the bottom it says audit free. Okay, go for that one. I'm a science fiction author. Okay, so I'm happy to email anyone 5 free chapters. Don't go to Amazon and order books. Get the chapters, find out if the style appeals to you first, and it's why not. Our website has Rick's art, space art, some of my you can tell the difference. space art, and a background on all my alien languages and so forth and all that jazz. Okay, so where have writers been putting aliens for since the 1930s? The G-type stars who are closest to us, okay? And as we also know, it's red dwarfs that are actually an even equivalently good place to look for intelligent alien life. These writers, if they're not very scientifically inclined, may make the mistake of putting aliens, intelligent aliens, right, or even bacteria around young hot stars. Very bad bet.
Yeah, and the reason for
Yeah.
this is you can see Sirius in the sky.
Yeah,
If
everybody
you're,
knows
if
it.
you're in the southern hemisphere, you can see Canopus. That's second only to Sirius in
Uh-huh.
brightness.
Uh-huh.
Fomalhaut is easily visible
Yeah.
from here in Oregon.
Yeah,
So why not? Put them
Yeah.
around Rigel.
yeah,
they do it all the
Rigelians. Everybody's
time,
got
but
Rigelians.
these stars are
No,
not old enough. The
no,
planets are not old enough to have
Yeah.
much more than maybe
Yeah.
bacteria.
yeah. And in many cases, not even that, because the planets haven't even formed yet.
Yeah.
Okay, red dwarfs. And one of the things that's interesting is the a lot of the planets that are close in, especially to the red dwarfs, are known as eyeball planets because they have one side that is tidally locked, or the planet is tidally locked, and one side is always facing the star. One side of the planet is always facing away. Okay.
Sort of like the moon.
Yeah, like our moon. Yeah, right. So you in that situation like that, if you had surface water, you'd have slush on one side and maybe solid ice on the other. Anyway, and one of the things this class has been focusing on is to broaden your idea of where life might occur. It doesn't have to be a full-on rocky planet with water. It could be, an icy planet with a warm ocean under the ice. It could be a moon, right? Because a lot of the interesting, options for life in our solar system are moons, right? There's one planet and a whole bunch of moons. So, and the reason Rick's going, oh, is because if it's hard for us to detect small planets around other stars, we're never going to find moons unless they're gigantic planet-sized moons. Yeah. In this scenario, it's still unlikely. And one of the things that I've made jokes in the past about we humans, one reason why we want to find other intelligent life emotionally, we want to find other intelligent life out there is because of that joy of discovering all these differences, right? That ways that an individual can be intelligent while being very different from a human being. And those of us who are pet lovers, right? Or birders. Birds are amazingly intelligent. They've got the intelligence abilities, problem-solving abilities of primates, packed into, and their brains are not anywhere similar to mammal brains. But we can if we're lonely for another intelligence, there are some options here on Earth, and while we wait for, and hopefully not invading evil aliens like these guys, nice aliens. But we have some nice intelligence here on Earth. We have our dogs, we have our cats, we have rabbits. Oh my gosh, yes, we have a class where we talk about the intelligence of rabbits, pet rabbits, and birds, right? So we do have some image, we have some options. Okay. And Rick is going to take you on a visual journey to the most likely candidates in our solar system.
Okay, here we have a view from the surface of Ceres, which is the nearest dwarf planet to the Earth. It's also the largest object in the main asteroid belt orbiting between Mars and Jupiter. We're looking out over Akator crater, which is one of the largest features on Ceres. And the white area in the center there has been found by the NASA Dawn space probe to be a salt dome like those you find on the Gulf Coast of the United States. And also there were indications of whiffs of water vapor being emitted from this feature. So I have it shown there as little faint emissions. Okay, next. And here we're out to Saturn's orbit. This is a moon of Saturn, Enceladus. It's barely 300 miles in diameter, but because it is tidally flexed between the planet's gravity and some heavier satellites farther out from Saturn than Enceladus, the interior has been warmed up to the point where there's an underground ocean that's emitting salty water vapor through cracks in the ice shell. All this was discovered by the Cassini spacecraft a few years ago. Here we're orbiting Jupiter. This is the largest of the Galilean satellites of Jupiter, easily visible through a small telescope, and if you're sharp-eyed, even through binoculars. What you're looking at there is something called a cryovolcano that's erupting a slushy water ice dirt mixture rather than lava. This was discovered by the NASA Galileo space probe.
Ganymede is the largest moon in the entire solar system, isn't it?
Yeah. And what this cosmic cryovolcano is telling us is that there is a deep underground, there's an ocean, probably salty water once again. The Galileo satellite also discovered a magnetic field, intrinsic magnetic field around Ganymede, like the one we have at the Earth, which is probably generated by currents in that underground ocean.
So it's not a hot, rocky core. It's currents of warm salt water moving under ice. Yeah, okay.
And here we are again orbiting Jupiter. This is another one of the big Galilean satellites. This one also easily visible through a telescope. It was found by the Voyager spacecraft to be almost as smooth as a billiard ball, covered in an ice shell that's full of thousands of cracks. And the Hubble Space Telescope discovered water vapor being emitted through these cracks, again indicating the presence of an ocean under the ice layer.
It was Europa that featured in 2010, the science fiction movie. Yeah. And speaking of these Galilean satellites, they were discovered by Galileo using the first modern telescope. He pointed it, at the sky and looked at the moon, and then he looked at Jupiter, which was an orb in his tiny little telescope. And he saw 4 satellites, moving over the course of days, right, and weeks, and he realized that yes, these are orbiting. And that model of moons orbiting Jupiter convinced him that Copernicus, who had absolutely no observational data to prove that the Earth was not the center of the universe, that the sun was, the solar system, that the sun was. But he looked at Jupiter and he said, this is a model. This shows us that a big object has little objects around it. So Copernicus's idea is not completely insane. So that's why they're called the Galilean, because he found them. He saw them first.
Okay, now we're back out at Saturn's orbit. This is the surface of Titan, largest moon orbiting Saturn, and the only moon with a dense atmosphere, about 4 times as dense as the Earth's atmosphere, in fact. But it's very cold there. In fact, what you're looking at is an inlet of a giant polar sea of what amounts to liquefied natural gas. It's a combination of methane, ethane, and some higher similar compounds. Now, what is interesting about Titan is not so much the methane ocean that was discovered there, but the water ocean that's deep underground, once again, just like on Ganymede. And again, this was various particles and fields data picked up by the Cassini spacecraft.
Yeah, and you'll remember the some of the lab experiments by John Lunine at Cornell. He's the one who created in his lab an artificial life form with the chemical components that we see here on the surface of Titan. And also on the left hand there, lower left.
Yeah, that's a methane river delta.
Yeah, you recognize the delta.
Yeah, they have methane rainstorms. In fact, some of them are torrential, almost like monsoons, that again have been observed by the Cassini spacecraft.
The nice thing about Titan is that it's been visited recently by Cassini and Huygens.
Yeah.
So we've got two. We can say this isn't an artifact glitch. These things were seen twice by two different
in situ on the ground by Huygens, and then from orbit via the Cassini spacecraft. And now we're out at Neptune. That's the farthest planet from the sun. And this is the largest moon of Neptune, named Triton. And back in 1989, the Voyager spacecraft discovered these sooty geysers being emitted from the polar cap on Triton. The polar cap was found to be solidified nitrogen, and as the cap emerges from almost a century of winter darkness, the sun is now vaporizing the nitrogen, and it breaks through the crust to form these geysers. Now, Triton also, there are some indications there may be deep underground an ocean of salt water. And now out to Pluto, the brightest of the various dwarf planets out there, actually the brightest Kuiper Belt object, I should say, and one of the largest dwarf planets.
Not very large, but the largest compared to planets and moons.
It's about a fifth the mass of the moon.
Yeah,
so
but
Pluto could orbit the moon if the moon were out by itself.
Go ahead.
What you're looking at here, probably the largest snow cornices in the solar system. The snow is not water, it's solid nitrogen. And the lake, the surface in front is the frozen surface of a nitrogen lake.
Do we know why the frozen nitrogen appeared pink previously,
Oh.
and it looks like blue. Is
Yeah.
that artistic license?
No,
No, that's
no,
chemistry.
no. What's going on with Triton was there are some contaminants in the, or impurities in the nitrogen, that it's hydrocarbon
Mm.
materials.
Mhm, mhm.
And the nitrogen snow is very fresh at Pluto because of the orbital dynamics of Pluto vis-a-vis those of Triton.
Yeah, Pluto is enormously far out there. Okay, so summarizing the class, when are we going to find biology? Practically anytime the chemistry is correct, and we believe that to be a very good conclusion based on what we now know about how life emerged on Earth. Life needs a quiet, agitated medium, right? So that the pieces of a large complex molecule can come together, and that the bonds can, can occur. It needs some kind of an energy source, either chemical, or the heat, or that's why we keep emphasizing these are warm under ice oceans, indicating that friction or magma or something is creating a heat source, right? Does there have to be water? Well, probably not. We've done lab experiments with other solvents. Water is the best. Right.
So that methane ocean on Titan may yet have methane based microbial life. I don't think we'll have methane based whales or anything like that, but microbial life, quite possible.
Yeah. And the false positives, the first important principle is, when you hear something exciting, deep breath. And then before you take anything seriously, insist on multiple lines of evidence.
As Carl Sagan once said, extraordinary claims require extraordinary evidence. Best way to get extraordinary evidence is multiple lines of evidence.
Yeah, and some of us who are not planetary scientists have been gung-ho, oh, let's colonize Mars, let's send human beings to Jupiter. There's a reason to not do that beyond the moral issue of putting human beings in danger. We don't know enough about all of these worlds. The other thing is the immense cost, which is caused by needing life support and protection from radiation for human beings. Okay, these three bullets we don't necessarily think enough about, right? Those big old, clunk, 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 right? You could be wiping out an entire species, and it would be nice if we got a chance to detect them before you kill them, more mundane but more problematic is that because we are life, right? We ingest things, and then we have waste products. And in the movie The Martian, they showed human poop, right, being freeze dried and then put into a container, whatever that's called, the freeze-dried packet, right? And because he needed to survive, he broke them open. Now, the freeze-drying process should, I love that word, should, scientists love that word, kill the bacteria. However, by growing his potatoes and then having explosions right? If there were
Yeah.
any bacteria, you've just contaminated the planet with earth bacteria. And the more people you have, the more chances that somebody gets sloppy, somebody's in a hurry, they're tired, they're, don't care, whatever. Um, and you have contamination. You're also going to have contamination from all the life support equipment. Again, no matter how careful you are, nothing is infallible. And then the situation where every time a human being breathes out, right, you're breathing out everything that's inside your body to the outside world. So if there are respiratory viruses out there, flu and RSV and COVID at the moment, every time somebody who's infected, regardless of whether they feel sick, every time that person breathes out, there's a cloud of viral particles, right? And if you're on an alien world and you have an accident, a slow leak or a blowout, all these viral particles, right? Some of which don't make human beings sick, right? You can't, they're essential to our metabolism. They're essential to our lives, or they're neutral. We don't want to, completely remove all microorganisms from the human body. You kill somebody if you did that. Every time you have one of these little accidents, then spew, spew, spew.
I think it was Ray Bradbury brought this up in the Martian Chronicles.
Yeah.
Somebody brought chicken pox to Mars, and all the intelligent life forms, this was back in the bad old days, Mars had people on it. They all died of chicken pox. So
Yeah.
it was analogous to what happened to the indigenous population of the New World when smallpox was introduced. They had no
Accidentally.
immunity, and
Yeah.
95% of them just dropped dead.
Yeah. So just that second bullet again, bear in mind that 3/5 of your human poop is not food residue, it's bacteria.
Yeah, a lot of it
So it
dead, but
is
a lot of it alive.
yeah. So there we go. All right, class number 2 is going to be fun. This was all class number 1. Class number 2 is going to be fun. Rick is going to talk about how he and a group of MIT brainiacs created a world for the famous science fiction author. You may have heard Robert Forward. You may have heard of him. And we're going to be answering questions based on class number 1, and also anything and everything involved in the question of life beyond Earth. And that ought to keep us going for way more time than we actually have in a live class. But we are going to have fun. So don't forget to join us for that live class. And